Hey guys, my name is Kevin Carr. Today I'll be joining a Leetcode contest. So why should you join a Leetcode contest, or like why am I even attempting it? So not to be too nerdy, but if you think about when Goku went to face Vegeta in one of my favorite animes, Dragon Ball Z, he went for the hyperbolic time chamber. So that's just like a useless metaphor. Well, not useless, but it's just a wacky metaphor to kind of describe things you should do when you're practicing or improving your skill set. Is you should always have some goal that you can kind of compare yourself and get feedback from. So let's say that you're a weightlifter and you want to, strive for certain lifting or weight goals. Then you should join a weightlifting competition. If you're practice Brazilian Jiu-Jitsu, you should compete with other people. If you want to improve your programming interview skills, you should join these contests. Obviously, I don't think I'm going to be able to solve all these questions, especially not as fast as other people in the world, because this is a global competition, but it's going to be fun to at least try. And we're about to start in a minute, but before I do, I want to kind of emulate another YouTuber, Kevin Samuels, I watch. He has a fragrance of the night. Today's seltzer of the night will be Black Cherry from Whole Foods. So that's what I'm going to be drinking as I go through this. And usually in these Leetcode contests, they have around, I want to say, 4 questions, 3 to 4 questions. I'm going to try to solve as much as I can. If I don't think I can solve all of them, then I will stop at a natural starting point, but I will at least try to solve as many as I can, and then kind of just give you a recap of when I'm done. So let's get to it. All right, so the contest has started. Weekly contest 239. All right, let's see these questions. So the 4 questions that I have are the minimum distance to target element, splitting a string into descending consecutive values, minimum adjacent swaps to reach the kth smallest element, and minimum interval to include each query. So off the bat, some things I see is minimum distance. When I think of minimum distance, I think of the famous edit distance or Levi-Stein distance problem. So that's probably going to be a dynamic programming question. So I am typically pretty weak at dynamic programming questions. I'm trying to get better, but I might not be able to answer it. But that's fine. We'll try. And for the other ones, splitting a string, there's probably might be some two-pointer or manipulation of the string, so I think that would be one I could potentially solve. Minimum adjacent swaps, that might be using some type of heap or two-pointer solution, and then minimum interval to include each query. That might also involve some like min-heap stuff, so let's get to it. Okay, so minimum distance to the target element. Given an integer array nums, 0 index, and 2 integers, target and start, find in index I such that nums equals target. And absolute I minus start is minimized. Okay. Note the absolute is the absolute value of x. Okay. Return absolute I minus start. It is guaranteed the target exists in num. So the good thing there is, especially if you want to go through a programming interview, you kind of clarify these edge cases and these boundaries for the question. So what are your constraints? So something you could ask in this interview, if you don't have this question prompt or details, are, is it guaranteed I'm going to have an answer to this? Is this something I should check for in a base case? So let's look at the examples. Input 1, 2, 3, 4, 5. The reason I want to look at these inputs is because it's a little bit confusing to me how they phrase this. So I got to see what exactly they want as the answer to this. Okay, so we have this array. Target is 5. Start is 3. Okay, so if we have our target and start, so 0, 1, 2, 3, it starts at 4, right? And then we look for the nearest target 5. So nums 4 equals 5 is the only value equal to the target. So the answer is 4, that index, okay, minus start, which is 3. So that equals 1. Next we look at the start 0 right here in this array, and target equals 1. So that would be 0 because we're doing 0 minus 0. Again, that's that start equals 1. Okay. And the same thing, 1, start at 1, it'd be 0, same thing. Okay, I think this might be a little bit simpler than I thought. First I thought that this was going to require a lot of dynamic programming. I might be wrong, but let's try it out. So for this particular problem, I'm going to be using Java, so I'll probably be using Java for all of these, but yeah, let's just get to it. So then we would start for, okay, make sure this is good. So I'm going to start off with an integer that starts at start here, and then the nums, oops. And, you know, just because of some background noise, let me close the windows. Okay, let's get to it. Okay, so for the middle part, or the logical end of this problem, I'm going to do nums.length, and then I plus I. And like what I'm seeing right here is like, we're just looking for, okay, so I right here minus start. So yeah, we would want the closest, the nearest thing. So as soon as you find this condition, you would want to return it, I think. So current value, curval equals nums I. If curval equals the target, then we just return I think it's math, no, it's absolute. Might be math.absolute. I don't remember off the top of my head. So I minus start. And then we don't have to do return -1 because it's always going to exist. So let's see where these codes, this test takes us. Yeah, so math.absolute, so math.abs. I think that's our answer. Oh, it has to have a return statement, so okay, that's fine. We'll have that be -1 because it's never going to reach there. Your answer. Okay, so 5, 3. Okay, yeah, that's where it should be. Nice. Okay, so let's just submit it. Okay, so we got a wrong answer. Let's look at more details. Okay, that's fine. Let's look at this again. 5, 3, 6. It's the target is 5 and it starts at 2, 2, -1. Interesting. So it starts with this last one, and we're looking for 5. So it should be 2. Oh, okay. So we just return the last thing. All right. So return nums.length if nothing is found. Oh, nums.length -1. Okay. So it looks like from this problem, if it doesn't exist given a start index, then you want to just return the last element. Okay, so we start at, the target is 5, and we start at 2, 0, 1, 2, and we're looking for this last one right here. Okay, that's good. So we start at 2, 3, 4. So 4 minus start, which is in this case 2, equals 2. Oh, why is it equal 1? Let's look at this. So we start at 2. It says we start at 2. Okay, so maybe it is one base. Let's check. Given an integer array, 0 index, and 2 integers, find an index I such that is minimized. Oh, okay, so in that case, we can go left or right. Okay, that's interesting for this problem. So maybe I can do 2 while loops that go left and right, and then just take the minimal answer. Okay, I like that. Okay. Let's go back to that example. So we got 2. So like, yeah, this is closest right here. Okay, that makes sense. Okay, so I got to refactor this code. So in this case, I am just going to start. Let's do it. Int mid equals start. Actually, while start is greater than or equal to 0 and start is less than or equal to nums.length minus 1. We'll start there. And here we're going to keep that last one. So we're going to do a while. Oh, yeah. Okay. So we're going to go give one. So I'm going to create a variable called going left because I don't want to reset the start one, especially when I got to use it twice, and one in a while loop that's going all the way to the left and one that's going all the way to the right. Okay. Going right. Start. While R going left does not equal target. Going left minus while R going right does not equal target. Also, for both of these, I gotta make sure I have a condition where if it is going left goes below 0, it'll just quit, and then if it goes right beyond the array length, then it just goes through that. If both of them found 5, or like the target, sorry, then I'll take the minimum absolute value subtraction thing there, and then if only one is found, then just return that. So it's going to be like an if else statement. So going left is greater equal to 0. Going right is less than or equal to nums.length. And then we'll just have a simple one if going, R going left equals target and nums. So I gotta make sure there. So in this first condition, I'm just making sure that they both equal to target. Then I'll take the min of that. Going right equals target. Then I'm going to return math.absolute. Oh wait, a math.min. And then math.absolute of going left minus start, and math.absolute of going. Okay, so I gotta get rid of this one. I think that'll get rid of the index error. Okay, let's try that out. Nice, cool. So yeah, all I did here was, now that I kind of understood the question further, I realized that it is actually just looking at the minimum distance both ways. So that's a key thing here. So when you're getting this problem, I would, be calm and methodical about your approach. Ask the interviewer about the constraints. In this case, the constraint is like they literally want the minimum distance between your start and finding that value. In that case, I had initially assumed that I would only be going right, and that would be the only thing that mattered. But it was actually, if we looked at the second failed case, it was an array with 2 5s, and we start at 2. It was looking for the closest one, which was the item placed to the left. So what I just did here was I just used almost like a 2-pointer solution, but not really, but a while loop, and then going both ways until it found the target value. And then this else if statement is if both are found, or both those pointers equal the target, then we return the minimum. If one is null or not be able to be found, then you would just return whichever is viable. And if not, you just return the last element. So let's go to the other ones now. Back to contest. Okay, so this is question splitting a string into descending consecutive values. Let's see how this goes. So you're given a string S that constitutes of only digits. Check if we can split S into 2 or more non-empty substrings such that the numerical values of the substrings are in descending order. The difference between numerical values of every 2 substrings is equal to 1. So for example, string 009, 008, and 9. And descending order. So this is valid. Another example, the string S equals 001 can be split into 001, 001, 0, and then the third element equals 1. However, all these ways are bound because the numerical values 0101, 001 respectively, all of which are not in descending order. Return true if it's possible to split the S as described above, or false otherwise. Okay, so the interesting thing here is I think this could be done recursively and possibly with dynamic programming. I'll try to do it recursively, but it might get a time limit exceeded error, so I might have to skip this problem. So this first example has 1, 2, 3, 4. There's no way to split it up where it is in descending order. For here, you do 05, 004, and 3, so that's true. For this one, you could do 90. Oh, it's false. Yeah, 90, 80, 70, but that 1 makes it tricky. 9, 08, 07, 01. Maybe you could do that. This one's a little tricky because I think you can do that, like 9, 08, 07, 01. But I guess it doesn't see it that way. Yeah, you could just do 1,000 or 100. 199, 98. You do 1,000, 999, and 8 too. Oh, is okay, the difference too. Okay, so you're given a string S that constitutes only digits. Oh, and the difference is only equal to 1. Okay, so that's pretty cool. So yeah, that makes sense. 05, 004, 3, it's all by 1. Okay. So yeah, 100, 99, 98. Okay. So we process these, turn them into integers, like kind of transfer it into, yeah, like basically split these strings up, then convert it to a value, and then do like a check to see if they're all minus by 1. So I can do like a helper function, public boolean difference by 1. And actually I would just take a array like this. For int I equals 1, I minus r dot length if r dot length is less than or equal to 1, return false. Equal to 1, return false. If I map that absolute. So I want to make sure that difference is not greater than 1. Return false, else return true. So yeah, all I'm doing here is like I'm doing 2 pointers, like the current element at index I, and then the previous one I minus 1, and seeing if that absolute difference is greater than 1. If so, return false. If all the values have a difference of 1, then being able to what's it called? Oh, and it has to be descending too. So that's actually pretty good to know. So yeah, those should equal 1, and if they all have a descending difference of 1, then you return true. Okay, so actually I don't even need this absolute. I just have to change the direction. So it'll be r minus I. And then I'll do that computation first. Equals 1. Yep. Okay, now how do I convert these up to those different numbers? I wonder if there's just a way to like change it into okay, so I'm gonna have to do a split string helper, split string helper, which will be our recursive function. I might have to include some different inputs. And then I'm going to have to do one return string. And then I'll just remove leading ones. Oh, zeros. Okay, and then I can just do int I equals 0. Yeah, actually. Int I equals 0 while I is less than s dot length So I'm basically just trying to find the first number that isn't 0. Yeah, so while I is less than that, and then s dot char at I equals 0, then I'm going to have, that I plus plus, and I can do a return s dot substring I, and then it just goes all the way to the end. Okay. So then I just gotta return this one right here, return split string. I don't think it's gonna pass because of the time limit exceeded, but yeah, this is how I would do it recursively. I'm gonna include a integer array. Oh, I have to have a certain amount of numbers, don't I? So I might actually have to make this array list integer. Oh, that sucks. Okay, what? You gotta do what you gotta do. So yeah, why am I using an array list? Because the array list is dynamic. I can add to it. I don't have to specify the length at the outset. And I'm using a dynamic array because I don't know the size at the on the beginning of the problem. It can change depending on what the input is. And what else do I want to do? Okay, I'll worry about that later. What do I have to change here? Be size. Size right here. So this would be .get okay, in this case, yeah, we would iterate it through it. So yeah, I feel like we would want an index one that starts at 0 here. So now we have our list integer equals r, and then our starting index, which will be I. If I is less than or equal to, well, actually equal to, if I is greater than or equal to s dot length, return false. If I is equal to s dot length minus 1, then this is where we could do our check. Excuse me. How much time do I have? So I wouldn't necessarily want it to be the last one, because in that case, there's nothing else to split and put into that array. But actually that could be good because then I don't have to add something in this last one, so I can just actually check, return difference by 1 r. Okay, that's cool. And then else. So would I do a for loop here, or would I just continue? So I would do a substring from where it starts to the end of it. So maybe I need 2 pointers, so like one that starts and then one that's going forward. Maybe the for loop does work, but I do need that. Okay. It's like a int j. Does that int j make more sense going in a for loop in this else statement? I think it does. And j equals I plus 1. J is less than r dot size. J plus plus. Then we would just do, we would add to it and then we would remove it from that array. Okay. So then we could do it r dot add s dot substring I j r dot remove s r dot size minus 1. Okay, yeah, so this is true, return true, and then we can continue that. Perfect. Okay, cool. So I don't actually need to create a duplicate variable here. So in this case, like a permutation, we add that partition. With this loop 2, we're able to, if it's true, return true, and if it's false, then we'll just continue to remove it and then just go to the next one. So I think this may work, or it might get a time. Oops, I++, where's that? Oh, did I subtract something? Okay, I think I'm going to jump to the next problem and come back to this if it's possible. Oh, back to problem, back to contest. And you can kind of see here globally, like you can just see people crushing this, being able to solve everything in 17 minutes. So it's not my time, but it's fine. So I've got 48 minutes left. But these are some pretty cool problems. I like this. You're given minimum adjacent swaps to reach the kth smallest number. So you're given a string representing a large integer and an integer k. We call some integer wonderful if it is a permutation of the digits in num and is greater in value than num. There might be many wonderful integers, however, we only care about the smallest ones. For example, the number 5489, 355, 142. The first smallest wonderful number is 5489, 355, 214. So in this case, this first example, we switch 2, 1, and then 1, 4. Second case, 2, 4, 1. Then 4, 1, 2, then 4, 2, 1. In such a way that, yeah, okay. Okay. So yeah, you go right. So I'm assuming you go right to left, and yeah, you just try to move that up. So while k is greater than 0, int j int I equals num dot length -1, int j equals the same thing. So k minus 1. If I equals 0, then we reset it. -1. If j equals 0, then we reset it. -1. -1. Then we just do a swap helper function. Oh my god. Yeah, this one's a little bit above my skill level because I just realized you have to find a way to calculate the wonderful integer, which I'll be honest, this is going to be a little difficult for me. Like, I thought it would be easy, but then I realized you're supposed to do the minimum. So, for example, it makes sense for this one and this one. You just kind of have like the standard swaps, but it's asking for minimum swap. So, if you can find the fourth smallest wonderful number in 2 swaps, then that's the optimal way. I'm just finding a way to get the answer, which is crazy. Yeah, the thing is a dynamic programming problem, and I'm not too good at that, but good to know. I'll look at the solution later. Yeah, I would like to see it just. I'm gonna just see if I can find the fourth smallest wonderful number for the first prompt. See if my thinking was right, but yeah, I gotta look at this again. Equals s dot to char array. Those are j. So yeah, what I'm using right now to actually like swap the elements is just like a simple swapping pattern. So in Java, you create a temporary variable first, then you set the first element you want to swap with the second element. So I at the ith index equals I at the jth index, and then finally the last statement is I at the jth index equals that temporary variable you set, which has a value at the first I element. String. So string right here, maybe it's a string. Maybe it's dot value of. Yikes. Okay. I think it is just new string. Oh, because I didn't have that as. Oh, okay. No. Okay, that's perfect. So it actually is void. But I want to set this S to that. Yeah. Okay. So 142, 1489355 142. I want to be able to get 421. So let's see where I went wrong here. So oh yeah, after I swap them, I want to, yeah, okay, so I forgot to minus them out. J minus minus. Interesting. So yeah, I have a sliding thing, so why aren't these zeros? Oh, okay, I see. Or okay, so let's get rid of this one right here. I minus 1. Swap the elements. So this hasn't changed at all, which is interesting to me. Yeah, maybe I do need to return this. Okay, num equals return. That's better. Okay. Yeah, so it's actually changing now. So 4, 5, 8, 9, 3, 5, 5, 4. Okay, so at least it's changing. 5, 5, 4, 2, 1. 4, 1. Okay. 4, 2. Okay, so we switch 4 and 1, right? So 4 is greater than this. We switch it. Is this greater? No. So then you reset it. Oh, okay, I gotcha. I think I got this. We reset those. And then another one is or elements. Yeah. 1, 4, 2. Yeah, this one's a tricky one. I don't know how to solve this, but what I tried to do was like first create a function that was able to find this wonderful number next by kind of like switching these, but I'm getting lost in kind of this middle portion where I'm trying to find and swap the elements. So I don't think we'll be able to solve this one, but yeah, let me just go back to context and see if I can solve the second one. Intervals. You're given a 2D array intervals where intervals describe the ith interval staring at the left and right inclusive. The size of the intervals defined as the number of integers contained, or more formally, right? You're also given integer queries. The answer to the JF query is the size of the smallest interval I, such that left is okay. 3. 0, 1, 2, 3. Four minus 2 plus 1. Might be able to do this one. I think it's just going to take some processing. I wonder if these are sorted already. If not, yeah, I think I'm going to sort it first. So I believe it's arrays.sort intervals. And the comparison, I think it's, oh my God, what is it? Things like A, B, A0 less than B0. And then we can just like iterate through those. So we need an integer for those queries. So output equals new int. And then we want the size of those queries. So queries dot length. So 4. So yeah, I think it's going to be n squared time. For query, so int q queries for interval intervals if q is greater than or equal to interval 0, so that's start one. And actually, let me just make it a little bit more cleaner. So start int start. Int end equals interval 0. Greater than or equal to start. And q is less than or equal to end. Then we're going to return here for int I. So for this one, I'm just gonna like fill it with the integer max value, so I can use a min function within this nested for loop down below in order to find the minimal difference in the intervals. Well, actually, the code will self-describe. So for int I equals 0, I less than output dot length equals integer dot max value. Okay, so if this is the case, how does it go again? So the query is 2 plus 1. Where's the plus 1 come from? So right minus left plus 1. Okay, cool, gotcha. So this is where, oh yeah. Okay, so I would want to call this like, yeah, int j equals 0, j is less than int queries. That's fine. Dot length j plus plus query int q equals queries j and in that case we want output j equals math.min of output j and then end minus start plus 1. And then after this one, if output j equals integer dot max value, then output j equals -1. And then we want to return output. Okay, I had to look up how to sort it, so let's find that out. Sort arrays comparison lambda or stream. Actually, let me check on Algo Experts. Okay. Actually, merge intervals. Oh, integer.compare, that's why. All right, that's fine. Okay. Interval. 3, 3. Nice. Yeah, it's gonna have a time limit exceeded. I know it. That's fine. Oh man, I wish they would tell you, like, oh, man, is there a way to not use this for loop? Math.min. Yeah, I don't think I don't know how to do this, but I think this would work if on most of these. It's just as, yeah, it's going to be O(n) time. I mean, O(n) squared time. So, because I have to iterate through both of them. So maybe, no, the queries, yeah, like you would have to go through all of them. The arrays.sort. So this would be the time space complexity. So I'll just show you. I'm using a sort. So the time, because I'm using 2 for loops, I'm iterating through queries and intervals. It'd be plus n log n. So that would just get reduced to this n squared time. The space is going to be O(n) time, because I'm also doing that for output, but also because of sorting. I think it also adds some space when you're sorting. This depends. But I do believe this solves most of them except the time limit exceeded. So because it's n squared, it's going to be tough for those edge cases where you have a huge input. I don't know off the top of my head what I could do to like reduce that to linear arithmetic time or n log n time, or just reduce it to O(n) time. Yeah, that's tricky. Maybe if... No, you wouldn't want to combine it because... Yeah, because like then you have query 3, which you want it to be the smallest interval. But in this case, it does run successfully here. It's just when it has a big intervals or queries array, or both at the same time, it's going to run really inoptimally or unoptimally in terms of time complexity. I'm just going to submit it. I know it's not the perfect thing, but I think it actually solves the problem, which is pretty cool. So yeah, back to contest. So yeah, I was only able to solve one. This string, it may not have been the best way, but I think compared to my past performances in these contests, I actually attempted to solve all of them, even though not all of them succeeded, only one succeeded. I believe the last one, the minimum interval to include each query, that is working in my favor. Maybe I could remove the duplicate intervals, who knows? Yeah, that might be a case where you can remove duplicate ones. Because of sorting, you could do that. Maybe that would help, but I'm not sure. But at the end of the day, yeah, these Leetcode contests are no joke. You can actually see like how fast some of these people were able to do it. Like 17 minutes. Like obviously, I've been doing this for I don't know, around an hour and 20 minutes, and I was only able to scratch the surface with these questions, but it was a lot of fun. I do feel like I kind of pushed my boundaries here, especially with these harder questions. And I think a couple things to kind of highlight are when you're going through these question prompts, especially in an interview, you want to clarify for interviewer the constraints of the problem. Make sure you fully understand it. So for example, in my minimum distance to the target element, remember how I kind of at first confused the question that was only looking for the minimum distance or the first time it found an element that equals the target to the right, but that problem actually specified I should look both to the left and right to find that target, and then just choose the one with the minimum distance. In terms of splitting the string into descending consecutive values, I was attempting to do it in a recursive way, or one that kind of used like permutations, but that would have led to an inoptimal time limit exceeded as well. But the good thing about that is I kind of recognize the pattern. I recognize it as a dynamic programming problem. And why is that important is because remember, with any type of dynamic programming problem, there's a recursive relationship. Once you see that and you realize that you're trying to improve for time, you're trying to improve the time complexity, I think it's important to realize you have two avenues, actually like three. You can continue answering the recursive solution. You could probably use a greedy approach. You could use memoization or caching the results, and you can also use a dynamic table or dynamic programming to solve the question. In terms of minimum adjacent swaps, again, that was kind of me misunderstanding the question. It's a little bit complicated, but the swapping is another type of permutation question. So that could have possibly been solved by some dynamic programming or maybe memoization. I'm not sure about that one, to be completely honest, for this minimum interval to include each question. The cool thing here is that with a lot of these interval questions, you can ask, hey, is this already sorted? Because that'll take a lot of the processing away. But the reason I wanted to check if it was sorted is because it'd be almost optimal to check if, so if I sort this, maybe I can make this better. So if you have a target, right? So this query is looking for 2, right? So 2. I would only have to go less than or equal to 2. Yeah, so okay. So then I would just continue here. If Q is greater than, wait. Yeah, if Q is greater than or less than the start, less than if Q, let's make sure. If the start, okay. So if the start, if the start is less than or equal to Q, so if this is greater, then you just continue. So maybe that'll help out. Because I think that, so still time limit exceeded, but the cool thing is like by sorting this, I'm basically saying, hey, if the start time is greater, so in this case, 3, 6 right here, I don't need to check that because 2 is not in there, right? And also I can say if, let's take for 5, for example, if 5, the end is less than Q, then I don't need to check it either. Oh, okay, so I gotta just check this here. Okay, so let's check this here. So basically, if we sort these intervals, we know that there's some gateways. So in okay, so I still failed this, but the cool thing is I did improve it from my initial approach. The reason being is, see, this is sorted right here. If I have the target 4, right, I obviously check these and these, but there's no reason for, okay, 5's a better example. If I know the start and time, the end time is less than 5, I don't need to check it. In case of 2, if I know 2 is less than this start time, I don't need to check that, or this one right here. So I'm checking to see if like they're in range. Let's see. So 2. So yeah, if the end time is less than Q, and I don't need to check it. The start time is greater than Q, I don't need to check it. Okay, yeah, so this speeds it up because I don't check every single one. I don't have to process all that. Yeah, well, I'm gonna submit that and then call it quit. Oh, not quits, but yeah, I'm gonna call it some time for this. So there's a time limit exceeded. I'm gonna see what I can do to improve that when I get done with this. But yeah, overall, that's the Leetcode contest. I would recommend that you do it. It really tests your mettle, tests your skill set. It's another one of those pressure situations that help you prepare for interviews, or just if you feel like your algorithmic and data structures knowledge is a little bit lacking, it's another good way to practice. Obviously, you got to practice to be better. Some of these people are really good at competitive programming, so they're able to do it in kind of, astonishing few amount of minutes, especially with a great score. But it is a lot of fun, so I recommend you do it. And can't wait for you to check out my future videos. GG, good game. I got destroyed in this contest, but it was a lot of fun. So can't wait to upload some new videos. But thanks again. Here's the seltzer of the night, and hope you guys have a good day. Cheers.